Okay, so in this video we are going to look at one question concerning the synchronous machines, and the question is a 2300 volt 60 hertz 6-pole star connected synchronous motor is driving a constant torque load of 5000 Newton meters. The synchronous reactance of the motor is 6 ohms, and we need to compute the speed of the motor and the minimum excitation required to provide the needed torque. And then we need to draw a phasor diagram for the circuit. So the first thing I'm going to do, as always, is I'm going to draw my circuit diagram. So I have my basic circuit diagram here. It's a motor, so I set the current going in, and I have EF and VT. And VT from the circuit diagram, from the direction of IA, I could see that VT is equal to EF plus IAXS, and this VT is of course here 2300 volts, which is wrong. And why is that wrong? Because this is the phase voltage, and what is usually specified here, as in the cases we had before with transformers and induction machines, is the line-to-line voltage. So what I need to do is divide by the square root of 3. This is the most common mistake that students perhaps make in attempting these questions. And similarly, if you were given the excitation voltage in the question, you would also have to divide it by root 3. It's always the phase voltages that we work with. So I want to find first of all the speed of the motor. And to determine the speed of the motor, it's just like in the induction machine. If I find the synchronous speed, it depends on the frequency and the number of poles. So to begin with, I want to find the speed in RPM. So here I have 60 multiplied by the frequency cycles per second. I multiply by 60 to get cycles per minute, and then I divide by the number of pole pairs to find what is the mechanical speed. Remember, the number of pole pairs will convert the number of electrical cycles to the number of mechanical cycles. So this is a simple calculation. I don't have any slip or anything. It's just the synchronous speed. That is the speed of the rotor. And the next thing I want to do is find the minimum excitation required, which is EF. I know T is equal to P on omega S, which is 3 VTEF on omega S XS sine delta. Remember, in this case, 3 VTEF, these are both phase voltages. So I want to find what is that minimum excitation. Now I know omega S is 2 pi omega S is equal to 2 pi F, right, which is our electrical frequency. So I have here the 5000, which is my load torque, is equal to 3 VT, which is 2300 on root 3 EF, over 2 pi 60 multiplied by 6, which is my XS. So I just make EF the subject of the formula, and then I will get 946 volts as the minimum excitation. What happened to the sine delta? So all of these other things here are constant. To get the minimum excitation, if you remember what a sine function looks like, right? And actually it will be, we'll only be looking at this part for the system, just the first half cycle of the sine wave. So when would EF be a minimum? EF will be a minimum if we have to satisfy this equation. EF will be a minimum when sine delta is a maximum. If sine delta is very small, then EF will need to be larger in order to give you to satisfy the equality. So when sine delta is 1, we have this condition here. Which means that delta is equal to 90 degrees. So we're going to use this information now to construct our circuit, our phasor diagram. So we have our circuit diagram, we have this, we know that delta is equal to 90 degrees, which is the angle between VT and EF. So we start off by drawing VT. Then I need to put in EF. Now, does EF go at positive or negative 90 degrees? Here I've drawn it at 90 degrees. Why is that? It's simply because we have a motor, so the power angle will be negative. The electrical system is pulling along the mechanical system. So VT, which is the electrical vector, the magnetic flux will be that is associated with the electrical side, will be ahead of the magnetic flux associated with the mechanical side, the stator side and the rotor side. And then I want to get what is IAXS, which I could get straight from my equation, because I know VT is equal to EF plus IAXS. So this is my phasor diagram. If I want to find out where IA is, IA would need to be perpendicular to IAXS, so that when I multiply by XS, which is J6, it would shift, it would give me a vector that is at 90 degrees to IA, which is this vector here. So that is how you go through the process of using your circuit diagram and your phasor diagram in order to solve a system with the synchronous machine. And I will post up some more solutions as we go along and you finish your tutorials and so on with other types of questions. So by now you should be able to write the circuit equations for the equivalent circuit and solve for voltages and currents using the equivalent circuit and explain the terms overexcitation and underexcitation. This of course is a summary for not only this example but the previous video as well.